Hello, my dear students. Uh, I'm trying to cover some important skills in calculus. So let's start this revision. First one, if you have y equal to sine 9x like this. So if we want to get first derivative, so 2 sine 9x, it will be what? The derivative of sine, it will be cosine 9x, okay? And as you can see, I have left space for chain rule. So we have to get the derivative of the angle also. So what is the derivative of 9x? It will be 9. So 2 times 9 is 18 cosine 9x. Okay. So this is what first derivative. Second, evaluate the derivative of fx. 2x minus 4 power 4 at x equal 1. So you'll get the first y prime, then substitute 1 for x. Here, f prime of x, I will get the derivative of the brackets firstly. So 4 multiply 2x minus 4 to the power 3. Decreased this power by 1. Then multiply it by the derivative inside the bracket to keep chain rule. So this is 2. Okay, so what is the derivative inside the bracket? It will be 2. Here, 2x minus 4 is the derivative. It will be 2. Finally, you will write 8. 4 times 2 is 8. 2x minus 4 power 3. Then evaluate x for 1. So 8, it will be 2 times 1 minus 4 power 3. And get its value by using calculator. Number 3, it will be y equal e to the power x power 2. So the derivative here, follow this rule. If you have e power u, so its derivative, its first derivative y prime, it will be the same e power u times u prime. Okay, so the derivative of the exponent, the same. So here, y prime is the same e to the power x power 2 multiplied by the derivative of this exponent, which is 2x. Okay, so 2x multiply e to the power 2x. Number 3, y equal tan times x squared minus 4. So the derivative for tan is secant square. Secant square, same angle, as you can see, x squared minus 4, multiplied by the derivative of the angle, which is 2x. Okay, so what is the derivative of this angle? Yes, 2x. So find the derivative is of y equal log x squared to the base 2. So the argument here is what? The argument is x squared. So if I want to apply the rule, log u, here base, this is the function. If I want to get its derivative, so it will be 1 over the argument u, multiply ln the base a, multiplied by what? The derivative of the argument. So apply this rule here. So y prime is 1 over the argument, which is x squared, multiply ln 2, multiplied by the derivative of this argument, which is 2x. Then simplify it to the simplest form, so it will be 2 over x ln 2. Cosecant 2x. Yes, I have here a triangle to save this into your mind. So this is cotan, cosecant, cosecant. Okay, and we have here what? We have here minus. So what is the derivative of cosecant? It will be negative cosecant cotan. Negative cosecant cotan. So y prime is negative cosecant 2x cotan 2x. Okay, multiplied by the derivative of 2x, which is 2. Okay. What about ln? The derivative for ln? Yes, y equal ln u. So its derivative, it will be 1 over u multiply u prime. Okay? So if I want to get the first derivative here, so I will make 1 over the argument, which is 2x plus 7, multiplied by the derivative of the argument. The derivative of the argument here, it will be 2. Y equal 2 to the power x. What is the derivative here? This is y equal a to the power u. So its derivative, it will be the same, a to the power u, multiplied by ln a, multiplied by the derivative of the exponent. Okay? So here, y prime is 2 to the power x, multiply ln 2, and the derivative of x is 1. Okay. Here we have an implicit differentiation because y is not isolated. Y is multiplied by x. So I will make an operator d by dx for both sides. And the first side, it will be what? X times y. And here 6. So the first derivative, or the derivative here, I will use a power rule. First times the derivative second plus second multiplied derivative first, which is 1, equals 0. Then try to isolate y prime. So y prime is, move this to the other side, so it will be negative y over x. Implicit differentiation again here, it will be 16x plus 16y y prime. Don't forget y, because y here is not x. So if you want to get the derivative for any letter or any variable other than x, so you have to add y prime. For example, if you have z power 3 and you want to differentiate it with respect to x, so you have 3zx squared z prime or dz by dx, okay? And this is 0. Divide by 16 to simplify this one. And y prime is negative x over y, finally. Okay, about this one, this with respect to t. So I will make first derivative t. So here 5, 7 minus 4t to the power 6, 4, multiplied by the derivative of what inside the bracket, which is negative 24t power 5. So it will be what? It will be negative 120 t power 5, 7 minus 4t power 6 power 4. Implicit differentiation again here, y cubed, so 3y squared y prime plus 2y y prime minus 5y prime equal 2x. I moved this to the other side and get the derivative directly. Why I moved this to the other side, which is x squared, which is its derivative 2x? Because I want to take this y prime as a highest common factor. So y prime is, after taking highest common factor, 3y squared plus 2y minus 5 is 2x. Then y prime is 2x over 3y squared plus 2y minus 5. Okay? What is the derivative of 10 to the power 2x? This is an exponential function. So here, the same power, which is 10 to the power 2x, multiplied by ln, the base, multiplied by the derivative of this power, which is 2. Okay? What about here cosine? 2 cosine x cubed. 2 cosine x cubed, so you have here y prime is 2. The derivative of cosine is negative sine x cubed, okay? Then multiplied by the derivative of this angle, which is 3x squared. So finally, it will be negative 6x squared sine x cubed, okay? Here's the derivative. Again, dy by dx, which is means y prime. So implicit differentiation here, it will be 2x minus 3y squared y prime is 0. Isolate this y prime as usual. So it will be 2x over 3y squared. y prime here, this 3, it will be the coefficient, 2x power 4 minus 10 to the power 2 multiplied by this, the derivative of 2x power 4, which is 8x cubed. Okay, multiply the 3 times 8, 24x cubed, 2x power 4 minus 10 to the power 2. Here y prime, the same exponent, 3x minus 1, multiplied by the derivative of this one, 3. Derivative exponent. Arcsine. We have a rule for arcsine, which is 1 over square root 1 minus this power 2. This angle power 2. Multiplied by the exponent of this angle, which is 3x squared. Here also, y prime, arctan. We have a rule for arctan, 1 over x squared plus 1. So it will be what? It will be x squared plus 1 here. So what is the angle? So it will be e to the power 5x power 2. Okay, 1. And multiplied by the derivative of the e power 2 5x. So it will be 5 e to the power 5x here. Okay. We have a rule for arcsecant. I encourage you to pause the video and solve it by your own. Yes. What about the first or the derivative of inverse function? To get the derivative of inverse function, we have a rule. Yes, we want to replace this m with 63, firstly. So f inverse of, it will be 63. It will be 1 over f prime of f inverse of 63. So we need now f inverse of 63. So we are using the original function here, x cubed minus 1, to get the value of x and the function equals 63. So here I will solve this for x. So it will be 64, take cube root for both sides. So it will be x, it will be what here? It will be cube root for this one, 4. So f of 4, it will be 63. So the inverse is obvious now. The inverse of 63 gives 4. Okay, so I will make it 1 over the first derivative of 4, because I will replace this with 4. So now I will get the first derivative at 4. So what is the first derivative at x equal 4? So with the first derivative here, it will be 3x squared. Replace x with 4. So 3 times 16, which is 48. So the final result will be 1 over 48. Similarly, this one. Find the critical numbers of y equal x cubed minus 6x plus 1. So we have to get the first derivative, y equal. To get the critical numbers, we have to equate the first derivative to 0. So 3x squared minus 6 equal to 0. So 3x squared equals 6. So x squared will be 2. So x will be positive and negative square root 2. So the critical numbers are root 2 and negative square root 2. Find the absolute extrema of this function. We have to get the critical number first. Sorry. So it will be negative for x and equal first derivative to 0 to get the critical number. So x will be 0. So I will get the value of the function at 0, and at negative 2, and at 1. Why negative 2 and 1? Because we have here the initial values of the interval. Negative 2 and negative 1. Negative 2, negative 1. And they get the value here. F of 0 here in the absolute function. So it will be 8 minus 2 times 0. It will be 8. 8 minus 2 times negative 2 power 2. 8 minus 2 times 1 power 2. And they get the value. Here, 8 minus 2 times negative 2 power 2 is 4. 4 times 2, 8. Here is 0. And here is what? And here is 2. 8 minus 2 will be 6. So this is the maximum value. Maximum. And this is the minimum value. This is for absolute extrema. Find the equation of the tangent line. To get the equation of the tangent line, firstly, I have to get the slope. So to get the slope, we have to get the first derivative at x equal 1. So at x equal 1, this is the slope. Okay? So here, the first derivative will be 9x squared minus 4. Replace this x with 1. So 9 times 1 power 2 minus 4. So you will get 5. So the slope is 5. Substitute in the point slope form, 1 minus y1 equal mx minus x1. So substitute in this function, y minus y1 is 1. This is y1. And this is x1. Slope is 5. What I've got here equal x minus x1 is 1. So this is the equation of the tangent line of this function. To get the slope, we have to get the first derivative and substitute x for -1 and y for 3. So to get the first derivative here, I will use implicit differentiation. So 2x plus 6y, y prime equals 0. Okay, then substitute x for, so 2 times -1 plus 6 times y is 3 and what times y prime equals 0, and then solve it. So it will be -2 plus 18 y prime equals 0, so y prime is 1/9. Thank you for listening.